Okay, start.
Okay, Assalamualaikum. We are from group uh, to present about biodegradable polymers. Next. Okay, next. First is about introduction about biodegradable polymer. Biodegradable polymer. Biodegradable polymer are type of plastic that can be broken down by a natural process into a smaller molecule and eventually into carbon dioxide and water. These materials are designed to be environmentally friendly alternative to traditional plastic, which can take hundreds of years to degrade in the environment. Biodegradable polymer can be made from natural material such as starch, cellulose, and proteins, or from synthetic materials such as polylactic acid (PLA) and polyhydroxyalketones (PHS). These materials have a wide range of potential applications, including in packaging, agriculture, and medical devices. However, it's important to note the biodegradable polymer still require specific conditions to degrade, and they may not always be the best solution for reducing plastic waste. Next. Okay, next. Process of biodegradable polymer. The process of creating biodegradable polymer can vary depending on the type of polymer and specific material used. However, a general overview of the process is as follows. First is selection of raw material. Natural material such as starch, glacier, or lactic acid are selected as the base for the biodegradable polymer. Second is extraction and purification. The raw materials are extracted and purified to remove impurities. Third, chemical modification. That is, the pure raw material are chemically modified to create polymer. This can involve processes such as polymerization, where molecules of the raw materials are linked together to form a long-chain polymer. Fourth is processing and shaping. The polymer is the process shaped into desired form, such as bag, container, and packaging material. Fifth is testing and evaluation. The biodegradable polymer is tested and evaluated to ensure that meets the necessary standard of biodegradability. Six is the packaging and distribution. The biodegradable polymer is packaged and distributed for use in various applications. Finally, it is important to note not all biodegradable polymers are created equal. Some some may take longer to degrade than others. Research is ongoing to improve the biodegradability of the materials and to find a new sustainable raw material for use in biodegradable polymer.
Next. Next, I will explain about structures of the biodegradable polymer. First one is biodegradable polymer tend to consist of ester, amide, or either one. In general, biodegradable polymers can be grouped into two large groups based on their structure and synthesis. One of these groups is agropolymers, or those derived from biomass. The other consists of biopolyester, which are those derived from microorganisms. Agropolymers include polysaccharide like starch found in potatoes and proteins such as animal. Polysaccharides consist of glycosidic bond, which take a hemiacetal of a saccharide and binds it to an alcohol via loss of water. Proteins are made from amino acids, which contain various functional groups. These amino acids comes together again through condensation reaction to form peptide bond, which consists of amide functional groups. Example of biopolyester include polyhydroxybutyrate and polylactic acid. Next, this is the biodegradable polymer organization based on structure and occurrence based on what I explained above. Next, uh, this is properties of the biodegradable polymer. All biodegradable polymers should be stable and durable enough for use in your particular application. But upon disposal, they should easily break down. Another commonality of this polymer is their hydrophilicity. Hydrophobic polymers and group will prevent an enzyme from easily interacting if the water-soluble enzyme cannot easily get in contact with the polymer. Polymer, specifically biodegradable polymer, have extremely strong carbon backbones that are difficult to break, such that degradation often starts from the end group. Since the degradation begins at the end, a high surface area is common as it allows easy access for either the chemical, light, or organism. Other properties of biodegradable polymer that are common among those used for medical usage include being non-toxic, capable of maintaining good mechanical integrity until degrade, and capable of controlled rates of degradation. That's all from me.
Okay, so now I present the next one, which is performance of the biodegradable polymer. First is biodegradable polymers are designed to break down into natural substance such as carbon dioxide and water rather than remain as plastic waste in the environment. Biodegradable polymers can be used in a wide range of applications, including packaging, agriculture, and medicine. Biodegradable polymers are typically made from natural, renewable materials such as starch, cellulose, and lactic acid. The rate at which biodegradable polymers break down can vary depending on the polymer, the conditions under which it is used, and presence of microorganisms. Biodegradable polymers can have a higher cost than traditional plastics, but the cost is decreasing as the technology improves and the production increases. And lastly, biodegradable polymers' mechanical and thermal properties may not be as good as traditional plastics, but it's still suitable for many applications. Okay, and the last one is the interrelation of the biodegradable polymer. First is the environmental impact. Biodegradable polymers can help reduce the amount of plastic waste in the environment as they can be broken down into natural substance rather than lingering for hundreds of years. Second one is composting. Biodegradable polymers are often used in composting as they break down easily and do not harm the composting process. Third is packaging. Biodegradable polymers are often used in packaging, such as for food and beverage products, to reduce the environmental impact of packaging waste. And the fourth one is the biodegradability. Different biodegradable polymers have different rates of biodegradability and varying end products. It depends on the chemical structure and properties. Fifth one is cost. Biodegradable polymers are more expensive to produce than traditional plastics, which can make them less accessible to some manufacturers. And last one is the performance. Biodegradable polymer may not be as strong as or durable as traditional plastics, which can limit their use in certain applications. Okay, so that's all from us. Thank you.